Multiplying and dividing radical expressions. So when we're multiplying radical expressions, first we have to make sure that the index is the same. Then you just want to multiply whatever terms are underneath the radicals together. So if we're multiplying these two terms together, we would have that same index, and we would just have a times b under the radical. So let's work out a couple examples. In example 1, we have an index of 3, so we're going to keep that index of 3, and then we want to multiply what's underneath, 2 times 4, which is 8. And now we want to simplify. So let's go ahead and break down our 8. 8 is equal to 4 times 2. And then let's go ahead and keep simplifying. 4 breaks down to 2 times 2, and then we have this last 2. So remember, our index tells us how many we want to group. So we have this group of 3 2's, one of them gets out, and then the other 2 disappear, and nothing is left under the radical. So this is our simplified answer. In example 2, it looks a little bit more complicated just because we also have the variables in there, but we're going to treat this the same way. So let's go ahead and take a look at our index. We have an index of 4, so we're going to keep that 4, and let's multiply whatever has the same base. So 9 times 9, that's really 81. A to the 5th times a cubed. Remember, when you're multiplying like bases, you add those exponents. So we have a to the 8th, and then b to the 1st times b to the 9th. Again, we'll add those exponents, so we have b to the 10th. And now we want to simplify and break these terms down into groups of 4 so that we can take whatever we can out of the radical. So that 81 breaks down to 9 times 9. And then our a to the 8th, let's go ahead and group these exponents into groups of 4. So if we take a to the 4th, we can have another a to the 4th, and that gives us our a to the 8th. And then let's do the same with b to the 10th. We can pull out one group of b to the 4th, another group of b to the 4th, so that gives us 8, and then we have 2 extra, b squared. Now we need to keep breaking down our 9's. So 9 is equal to 3 times 3, and then this 9 is equal to 3 times 3. And then of course we have our a to the 4th times a to the 4th times b to the 4th times b to the 4th times b squared. And then we can go ahead and group. In 4's, we have a group of 4 3's, and then we have one a, 4th, another a to the 4th, a b to the 4th, another b to the 4th, and then we have a b squared that's going to be left inside with an index of 4. So our very last step is just simplifying everything we got out. So we have a 3 times a squared times b squared, and then we have an index of 4 with b squared underneath. And here is our simplified answer. When we're dividing radical expressions, we've talked about this idea before. You have one radical expression divided by another. And again, you have to make sure that they have the same index. Then what you can do is you can just write one big radical with that same index, and actually just put a over b underneath that radical. So let's work out a couple examples. In this first one, we make sure that the index is the same, and they're both 4, so we're actually going to combine those into one big radical, and then put 32 over 2 in there. So now we can actually divide 32 by 2, which gives us 16. And so now we can actually simplify 16 and find the 4th root of 16. So let's go ahead and simplify that down. 16 is equal to 4 times 4, and then let's keep breaking that down. 4 is equal to 2 times 2, and again this 4 is equal to 2 times 2. So here we have a group of 2's, and we have 4 of them. So because our index is 4, We can get one of those 2's out, the other 3 are gone, and this is our simplified answer. So let's go ahead and do that same thing with example 4. And again, I know it looks a little more complicated because of the variables, but we're going to treat it the same. We have the same index of 3, so we're going to go ahead and take that index of 3, and then we'll combine what's underneath, 81a to the 11th over 3a squared. Now let's go ahead and divide what we can underneath before we start simplifying. So 81 divided by 3 gives us 27. And remember, when you're dividing like bases, you want to subtract the exponents and then put that remaining base and exponent where the bigger exponent is. So 11 minus 2 is 9, and since 11 is bigger and it's on the top, we're going to put it on the top, a to the 9th, and then we've actually gotten rid of everything in the denominator. So now we can just focus on simplifying this term and then finding the cube root of that. So let's go ahead and break this down. 27 is equal to 9 times 3, and then a to the 9th, we can get that into 3 groups of 3. We have a cubed, and a cubed. That'll give us 3, 6, 9 a's. So we just need to break down our 9 one more time. 3 times 3, and then this 3 comes down, and then we have our a cubed, a cubed, a cubed. So again, here we have this group of 3. Oh, I forgot my index. Don't forget that, because we really don't want to forget that. It completely changes your answer. So we have 3 3's, so one of them gets out and the other 2 are gone. And here we could do this 2 different ways. Since we already grouped them in 3's, you can pull each one out, or since we happen to have 3 a cubes, we can actually group those in 3 and just pull one of those out. That makes our simplifying one step faster. So then this is going to be our final simplified answer. That's it for this set of notes. I'll see you in class for some more practice.